Hi, I'm Matt, and in this video we are going to go over one of the important gas laws known as Charles's Law. Before we start talking about Charles's Law, we have to discuss what temperature and what volume are first. So temperature is the average kinetic energy of the particles in a sample, and for gas laws it has to be measured in Kelvin. We cannot use Celsius in any of our equations, and we're going to have to convert to Kelvin before we can do the question. And then volume is the amount of space an object, such as gas particles, take up, and is usually measured in liters. Since we're going to have to convert temperatures to Kelvin, before we move forward, let's try an example of how to do it. So we're going to use the equation, the Kelvin temperature equals the Celsius temperature plus 273. So let's try to convert 27 degrees Celsius to Kelvin. We're going to use our formula and we're going to plug in 27 for C. So we get that Kelvin equals 27 plus 273. So our Kelvin temperature will be 300. So 27 degrees Celsius is equivalent to 300 Kelvin. And if we were doing a question with it, we would use the 300 Kelvin instead of the 27 degrees Celsius. With that out of the way, we can now start discussing Charles's Law, which states that the volume of a gas is directly proportional to the temperature in Kelvin, assuming that pressure remains constant. So as temperature increases, volume will increase as well. If temperature decreases, volume will decrease. Now, more specifically speaking, if we were to double the temperature, that will double the volume. And if we were to halve the temperature, that would halve the volume, assuming that those temperatures are in Kelvin. Now, it doesn't just have to be doubling and halving. For example, if we were to triple the temperature, the volume would triple as well. Due to this direct relationship seen on the last slide, if we were to make a volume versus temperature graph, we would get an upward sloping, linear, or straight line, as seen in the graph on the right. Moving more into the mathematical part of Charles's Law, we could write the law as V1 over T1 equals V2 over T2, where V1 is our initial volume, T1 is our initial temperature, V2 is our new volume, and T2 is our new temperature. So Charles's Law, written as an equation, is the initial volume over the initial temperature equals the new volume over the new temperature. Now, let's try two examples with this law. For our first example, we are told that a sample of gas initially has a volume of 10 liters. When the temperature is increased to 300 Kelvin, the volume increases to 15 liters. What was the initial temperature? So the first thing we're going to do with all of these questions is we're going to write our formula. V1 over T1 equals V2 over T2. And then on the side, we're going to list our givens. We're told the initial volume, or V1, is 10 liters. And then we don't know what our T1 is, because that's what we're solving for. V2, or our new volume, we are told was 15 liters. And then our T2, or our new temperature, we're told is 300 Kelvin. So now we're going to plug our givens into the question. So we have 10 liters over T1 equals 15 liters over 300 Kelvin. We're going to start off by doing the math on the right, and 15 divided by 300 is 0.05. And that equals 10 over T1. To solve for T1, we have to put 0.05 over 1 and then cross multiply. This gives us 0.05 T1 equals 10. And then to finish solving for T1, we have to divide by 0.05. And that gives us that T1, or our initial temperature, is equal to 200 Kelvin. For our second example, We have a sample of gas initially at 57 degrees Celsius, has a volume of 24 liters. If the temperature increases to 77 degrees Celsius, what is the new volume? So we're told that our initial volume is 24 liters. Now, we have a problem. Our initial temperature is in Celsius. So we're going to have to use Kelvin equals Celsius plus 273 to get a usable temperature. So we're going to plug in 57 and add it to 273 to get that T1 equals 330 Kelvin. We don't know what V2 is because that's what we're solving for. And then we run into the same issue with T2, that it is also in Kelvin. So we're going to do 77 plus 273. And that gives us that our T2, or our new temperature, is 350 Kelvin. Now that we have our givens, we could write our formula and start plugging in. Remember, the formula is V1 over T1 equals V2 over T2. And then we're going to plug in. So we have 24 liters over 330 Kelvin equals V2 over 350 Kelvin. We're going to start by doing the math on the left, which gives us 0.0727. I'm going to round everything to 4 decimal places for now, because the decimal repeats forever. And then that equals V2 over 350. To finish solving, we have to cross multiply. And we get that V2, because V2 times 1 is just V2, equals 350 times 0.0727, which gives us 25.45. Not that we want to worry too much about significant figures with this question, but since 24 is it has the least amount of sig figs, we would round to 2 significant figures and get that our new volume is equal to 25 liters. Now that we've gone through some examples together, here are 4 practice questions to test your understanding of Charles's law. Question 1 asks what 2 variables Charles' law describes a relationship between. Question 2 asks about the shape of a volume versus temperature graph. Question 3 asks what will happen to the volume if the temperature in Kelvin is tripled. And question 4 is a mathematical question. At this time, I encourage you to pause the video, and the answers to these questions will be provided for you on the next slide. The solutions are as follows. Charles's law discusses the relationship between temperature and volume. The graph between volume and temperature is an upward straight or linear line, as seen on the right. For question 3, if the temperature was tripled, the volume would triple as well. And then for the math question, you should have gotten that the new volume was 10 liters. If you didn't get that, remember that you had to convert the Celsius temperatures to Kelvin temperatures. Thank you so much for watching. If you have any questions, feel free to leave a comment below and I will get back to you as quickly as possible. Thank you so much for watching. Have a great day.